Okay, doors are closed. First of all, thank you very much for being here. It is an awesome pleasure to be here presenting for yourselves, and I really hope that you enjoyed the session. So, without further ado, andiamo. So my name is Antonio Vasconcelos. I work for Microsoft for 3 years and a half now as a Premier Field Engineer. Thank you for giving a sneak peek. I'm based in Portugal, but I work for EMEA, so I'm supporting a lot of Premier customers from Europe, Middle East, and Africa. And let me tell you that the life of a PFE is not easy. I mean, traveling every single week to a different country, alone, always alone, working through nights in data centers, in offices. It's really a tough life, as you can see.
Antonio, what was PFE again, just in case some of them don't know?
Oh, so a Premier Field Engineer is quite simple. We work to extinguish our position. We work for customers not to have reactive issues. So it's all about proactive engagement. We do a lot of risk analysis, or risk assessments, that is, education, making sure that customers make the best use of our solutions and are performant and protected. Shall I?
And I think I'm next. My name is Erdal. Great to see some faces.
Repeat that
back.
again, I'm sorry.
My name is Erdal. Great to see some of you back again. I think you know the story now, but I have to tell it for the ones that didn't attend my session. Probably not my accent, but promise not my fault. Let me tell you why. Turkish parents, born in Germany. For the last 16 years I was in Australia. Last 4 months I'm living in Dubai now. So this is what's coming out. I'm sorry, but promise you will get immune to the accent very soon. It's BitLocker encrypted, but the encryption key is given to you. I'm a university lecturer working in EMT Holding as Chief Information Security Officer. Doing my PhD. Very soon, hopefully, you can call me Dr. Skaya. All right, that's it.
Next slide. And
I think I should tell this.
Oh, yeah.
Who wants free swag? Sorry, my ears. Who wants free swag?
Okay, that's better.
All of you get a free swag. All what you have to do is tweet about the session. Here's the hashtags. All of you getting a free Zeman antivirus. Totally free. Plus, we have some other swags here to give away. All what you have to do is, for those ones here, ask questions. This one, you all got it. Enjoy it.
Awesome. Okay, let's go to the session objective, please.
All right. It's all about BitLocker. It's like my accent. So we are trying to show you today how you can strengthen your devices via encryption.
Exactly.
I remember, I was born in Germany, as I told you. Every time my parents speak Turkish, I knew I was in trouble because I couldn't understand the language, and it was encrypted. So hopefully today you are going to understand when and how you can use pre-authentication or not. Yeah. The more important thing is we want you to be secure, and this session is built to help you to be in a more secure environment.
More secure state, exactly. So although the session is BitLocker focused, a lot of the information that we're going to provide on attack vectors, they also apply to other encryption technologies, and you can also apply the same countermeasures. So at least if in the end of the day you'll have a better understanding of how to protect your devices, your information, we're all happy. Let's go quickly through the agenda. So I want to explain a bit better what is BitLocker, how we deal with the encryption keys, how we leverage TPM, the disk layout and key storage, just to also give an example of how we store the keys, how the keys are secured themselves, and when to use the pre-boot authentication or not. Pre-boot authentication is that PIN. I'll explain in a second. Then we'll move on to attacks and countermeasures. For each attack that we'll showcase, there's always recommended countermeasures or mitigations that you can apply. We'll talk about bootkits, DMA, and memory remnants, or a cold boot, cold memory attack. And in the end, in the search of the unicorn. And I have that nice Ninja Cat unicorn to show, but I cannot because of copyright violations anyways. But we'll try to give you like the summarized version of everything that you should consider when you want to protect your encrypted drive. Okay, let's move on.
All right, the question is here, why we should encrypt. Let me ask you first. Who's using encryption? Cool. Who's using BitLocker encryption? So all of you.
Well, nice
all
statistic.
Right. Who is not using encryption? Promise
okay,
you're going to use it after today because we're going to show you the real dangers. Okay, I'm pretty sure most of us did lose many stuff before, such as mobile phones, USB sticks, or believe it or not, people losing laptops. And based on the statistics, one laptop is lost or stolen per minute in the world.
How many of you lost a laptop or a cell phone? Hands up.
We have,
some, okay.
We have
nice.
Quite a few people. So 10,000 devices per week here in US airports.
Right, that's a lot, yeah.
Or 180,000 devices over 1 year for the ones that come from United Kingdom. Hello, Lois.
Lost or stolen, that is, right? And this is, I think, from 2012 statistics, so it's quite impressive. And if we are now working on this more mobile environment, mobile world, it's even more simple, more easy to lose our devices with our private information inside. So, and one more reason to protect the data with encryption.
And I'm pretty sure you watched or you heard about the news last week in the Build conference. Yeah. So Microsoft aims to have 1 billion devices with Windows in 2017, which means if you don't use encryption, even though now like Surface, we got Surface Team here, comes with inbuilt encryption there.
Pervasive encryption, yeah.
The cost is minimum $50,000 in either data breaches or loss.
Yeah. All the PR, legal work, trying to get your data back. It's not the cost of the device itself that's the problem, right? It's all of those issues that you get from losing confidential information. So again, go ahead.
Who is using third-party encryption? How much does it cost? $100 per year. Microsoft, how much does BitLocker cost?
0.
What does OOB mean then? Out of box, it's there for you, free.
And you have the cost of the license of Windows, naturally. Yeah, that's it.
And the good thing is, it's there for you to protect you against offline attacks. I'm pretty sure some of you attended my sessions. I can see some faces. You saw what we done on stage. It's there with various management options. So it's not just something which you enable and go. So what is if you forget or lose your password? What if
recover,
so you have many
you can recover. You can do like Active Directory, you can do Microsoft BitLocker and Administration Monitoring, which is MBAM, the acronyms. Or you can even do it yourself and save that information on secure devices or secure files to recover that key.
And the new mobile era is coming. I think this will be ideal solution for that era as well, right?
True. Thank you. So let's have a look at BitLocker, shall we? It was introduced in 2006 with Windows Vista. It was becoming quite trendy, the offline attacks. And I'm pretty sure that you, at least some point in time, heard that reading information from an offline machine is quite easy. And in there's a lot of valuable information from the OS, from your side also. You can get the SAM file and the passwords. You can go to the registry. You can get domain information, network information. So there's a huge spectrum of information that an attacker can get just by plugging in a USB stick into a computer, dumping that information to an external disk, and going away, not even with touching your machine. I'm pretty sure you also heard the term evil maid attacks, quite normal also. So you give a USB stick to someone, and that person employs that attack to a computer without even touching the computer. So the computer remains on site. It uses standard encryption algorithms, so nothing out of the blue, AES, CBC. By default, we empower 128-bit encryption size key, or key encryption size, I'm sorry. But you can choose to apply 256-bit. It will have a slightly bigger overhead than a 128-bit, but nothing that it's noticeable on nowadays computers. Right? In 2006, things were quite different. SSDs were not that common, and powerful CPUs were also not that common. Elephant diffuser, this is a nice story. So when the team that designed BitLocker back in 2006 were kind of deciding which ciphers to use, they also decided that they needed something else besides AES CBC, or at least back then. And they came up with this name, which is called Elephant Diffuser, and it basically applies short or mod operations after the ciphering is done, after the encryption is done, I mean with AES. And the Elephant was basically because they were studying other ciphers on the market already, and they were called Bear and Lion and Beast, and they thought that Elephant would be an appropriate name to give birth, to baptize, I mean. Anyways, Elephant Diffuser is not used anymore since Windows 8. We removed that for a myriad of reasons. First of all, it was not FIPS compliant. It was not hardware accelerated, while AES is by the CPU extensions. And a lot of other mitigations came into place to remove this need of having Elephant Diffuser in place. So, BitLocker is FIPS compliant. Hey! It supports for system drives, external drives, or fixed drives, like your data drives. So whatever you want to encrypt, we are capable of. The external drives, we call it Windows to Go. You can encrypt your USB sticks and even apply different rules to those. And also, we support integrity checking during the pre-boot, which is, in many cases, highly important. Requirements are simple. Like we said, it's free. It's out of the box. It comes with Windows. Back in the days of Windows 7, it was a bit more tricky because you needed an enterprise or ultimate license. The professional, and we do get a lot of those questions. Can I enable BitLocker in my Windows 7 professional? Sorry, no. Anyways, with Windows 8, we reduced a lot of the SKUs that we had, and even now the professional SKU has the ability to have BitLocker in place. Windows Server, all the SKUs support that, so array. You also need a trusted computing group bias to give you at least that chain of trust. Right? You want to really make sure that the bias is safe, it's not compromised. Otherwise, it will be like the low-level attack, and BitLocker will not be doing there anything. And this will naturally establish this root of trust with the TPM to give you that higher degree of security also. And the TPM, by the way, Trusted Platform Module, I'll explain it in the next slide. Although it's not a requirement, we highly recommend it. And Microsoft is doing a huge push in the industry, along with other partners also, to make TPM a standard thing on all of the devices, even for consumer devices, not only enterprise devices.
And here's TPM.
And there you go, TPM. By the way, if you have any question, please feel free. Oh, sure.
If you use the microphone, it will be much easier if you want to.
See, we'll have the explanation for that. Can you give me 5 minutes, or I'll go through those slides.
Repeat the question.
So the question was if you have only TPM as a protector without PIN, if you could boot Ultimate CD, was that it? Boot CD. We'll talk about that in a couple of slides. Thank you. So TPM is a hardware-based security module that allows you to do a lot of things, and the OS to take a profit from a myriad of things. Myriad of things. From perform crypto operations to PCRs, which is a platform measurements like ashes of everything that you have configured in terms of configuration, software configuration, or hardware configuration. And obviously creates, stores, and manages the keys, not only for BitLocker, but also for other things. And it's quite secure because it empowers a lot of security features, both physical and logical. From anti-hammering to tamper detection, there's a lot of sensors within the TPM. and it kind of detects if there's someone trying to wiring the TPM. Although there are quite advanced attacks nowadays, they are very difficult to apply. Active Shield, which is actually metal, it's like different layers of metal to protect the wirings of TPM, so no one can access that, and also memory encryption. So it's something very secure. There's a lot of vendors that have this and are producing this, and I'm pretty sure that the majority of your enterprise computers have them. And even small things like phones, it's quite common also. The Windows Phone 8 from Microsoft, it's a requirement to have a physical TPM on those phones. But things moving forward are a bit different. We have different technology that allows us to have the same security TPM offers without having that hardware module. And this is called Trusted Execution Environment. It was also something that the Trusted Computing Group started a couple of years ago, where we will make use of the CPU secure areas to virtualize all of the instructions that we normally rely from a TPM. So ARM has the technology that is called Trust Zone. Intel has a technology which is called Platform Trust Technology. And I put the image of Surface 3, not the Pro, but the Surface 3, which we launched this week, because it actually employs this technology from Intel. Right? There's no physical TPM in there, but we can benefit from the same set of features that TPM 2.0 gives us from the CPU itself. And this is obviously something major because it lowers the costs, and for cell phones, it's even more simple, or even more simple also, to reduce the form factors of those devices. Cool? Anyone knew this? I couldn't hear, sorry.
If you can use the microphone, please.
We still have a lot of clients on TPM 1.2. Are any of those features in 1.2, or is it all, do you have to have TPM 2.0?
2.0 adds an extra bit of features, so we do support 1.2 easily, no worries. Okay, you won't lose anything. But moving forward, maybe in a couple of years, probably 2 or 3 years, there might be specific features in TPM 2.0 that we will require for certain features in Windows. Okay?
By the way, for each question, reserved for you and you.
Okay. If you want to have a look in your computer, if you have a TPM and what kind of TPM you have, well, you can go to tpm.msc. That probably is more easy, but we are geeks, so here's the WMI class to get all of the details from the TPM. Another thing that differs from TPM 1.2 to the 2.0 is that the 2.0 is always active. There's no need to reset the machine, or restart the machine, I mean, to activate the TPM. It's always active. While the 1.2, it could be inactive. You had to go to the BIOS or UEFI, activate it, and then take ownership of the TPM. Taking ownership of the TPM means that there's a link of trust between the OS and the TPM, and then we can there store information, private information, that is going to be very important for things like BitLocker to work. If we lose that chain of trust, we need to clear the TPM, so we lose everything, and we have to reestablish or redo again the ownership. And the TPM is really a black box. There's nothing that we can manage from the OS point of view other than take ownership, reset. That's it. Right? It's really a black box. It's intended to be a black box. It's supposed to be secure, and we cannot manage that. And what kind of keys, and how can we protect information? How do we protect information with BitLocker? So a lot of acronyms, I'm sorry, but we have to go through them. Bear with me. First of all is key encryption keys. And this is what encrypts the volume master key. Okay? And the volume master key then encrypts what is called the full volume encryption key. And this last key is the one that encrypts the real information on your disk. All of those keys are highly protected, and those protectors, those KEKs, can be they can be multiple protectors, and it can actually also have multiple protectors combined. For example, the TPM, which is the most common one, empowers the system root key, or the storage root key, I'm sorry, which is an RSA key to encrypt the VMK, the volume master key. You can also do TPM plus PIN plus startup key. You can increase the complexity by a lot if you want. It's up to you. But nowadays, TPM is more than sufficient, and we'll explain why.
Question.
Sure.
Is there support for any other two-factor authentication for those keys or shortcut or anything like that?
Out of the box with
Repeat the
Windows.
question.
Oh, yeah, sorry. So the question was if we support second-factor authentication. Was that it? To the pre-boot authentication? Out of the box with Windows, no. There are third parties that you can see. I'll tell you the names after the session if you want. They can support, for example, smart card, fingerprint for the pre-boot authentication. Okay. For the pre-boot, but for not pre-boot, for data drives, for example, you can use smart cards. Okay. For fixed drives. Okay. Where are those encryption keys? So the system, the storage root key, I told you it was in TPM. What about the volume master key and the full volume encryption key? Those are stored in specific places in the volume. So once again, the storage root key is contained in the TPM, but the volume master key and the full volume encryption key are in the volume metadata. They are highly protected, and I'll show you that. And by the way, going back one slide, because I forgot to mention this. I see this type of keys and all of the protections in layers like a matryoshka, right? You have your information, and you have the full volume encryption key, and then the volume master key, and then you go to the keys or the protectors that you apply to those keys. So it's a protection really by layer. So let's explain how the machine boots and how those keys are released and how do we unseal the next key. So you turn on the machine, there's a beep, right? Beep. TPM releases the storage root key, which then we use to unseal the volume master key, which in turn we use to unseal the full volume encryption key, and then you'll have access to the sector that you want to read. And the information is actually also encrypted based on an independent vector, meaning that each sector will have a different encryption key. So it's not only one key to the entire volume.
Do you want to do some demo?
Yep, why not? So let me show you. Need to switch. There you go. All good?
Cool.
So for the demo, I created this basic VHD disk, as you can see. Just normal disk. It should be already mounted. Not. So let's go, double click. And it's asking me for the password. And this is the protected for this disk. There you go. Can you see it? So this is my C drive already encrypted. And you see the lock is open because it's unsealed, right? The information is now in clear text for the system. And it's important to refer once again. Any encryption technology is to protect you against offline attacks, not online attack. Once the system is on, a complete new sector or a complete new set of threats are in place, right? So anyways, I have my D disk encrypted, and I have here a CMD and X editor. I'd like to go and show you. You can see it. There you go. Manage BDE, it's the command line to manage BitLocker drive encryption, or disk encryption. And you have a lot of options there, like turning on, off, pause or resume the encryption. And also the most important ones that I want to show you is the protectors, right? Those to protect the encryption key. There you go. So I just have to do minus protectors, select the drive, and then I have some options. And the options are like get, add, delete, disable, and so on. You can actually add certain protectors after the encryption is done. So for example, you have TPM. You can then afterwards select PIN and add PIN to the TPM. So the question was if the storage root key is independent on each TPM. It's different, is that it? Each TPM will have its own set of keys also. It's everything different from TPM from TPM. Was that the question? Yes, exactly. Yeah.
That doesn't require re-encrypting the drive?
No. You're just adding another protector to protect the keys that are encrypted information. Sorry?
Repeat the question.
Okay. Oh, sorry, I didn't repeat the question. So the question was, once again, can I add the PIN after I have encryption done only with TPM? Yes, you can. Thank you. So here you go, manage BD protectors to my D drive, and I'm just listing the protectors that are applied. You can see the numerical password, which is that 48-digit password to recover the actual volume if you need to go into BitLocker recovery mode. Then the password, which is the one that I use to unlock in Windows. And finally, it's the external key, which is the back file, the BitLocker encryption key, if you want to do, for example, auto-unlock of this volume. Like you can associate an auto-unlock to that volume when you log on into Windows, so you don't need to type the password each time you log on. Right? And this will be only to your session. Yes?
So, I know you said that encryption is just to protect you against offline attacks.
Correct?
But say something like that crypto locker that went out a while back, if you were already encrypted with something like this, would that have provided protection against something like crypto locker?
Is that those ransomware attacks, the crypto locker? So, no. BitLocker will not protect you against ransomware attacks. Crypto locker, if I'm not wrong, is those kind of techniques where you receive a malware through an email and it will encrypt your personal information. Thing is, it's not even getting outside of your storage, of your profile. So there's no need to not even get an elevation or an elevated process. So you don't need admin for that. They just zip the files with a huge key, send the key back to China or a server back in whatever that is, and they will ask you for money. Right? Again, it's doing that encryption online. Right? It's not nothing that we can protect with BitLocker.
And in this case, you are allowing them. You are clicking. They're social engineering you in a way that you have to click somehow to get infected.
Yeah.
In this case, nobody can help you.
Well, you can try to not click that, but sometimes it might be difficult, right? Anyways, really? Really?
My boss. Wife. Hello, honey.
It's okay. Thank you. But anyways, do try to be careful with that. Add all of the online protections that you can, like antiviruses, anti-malware, and backups also. Right? That's it. I do have a lot of customers that unfortunately were targeted, and they lost a lot of things. Because backups, it's not only about doing the backup, but it's also about testing your backups. So when they wanted to restore their backups, oops, things are gone.
With backups, there's a big issue because most of the people, they have auto backup synchronized. And if you automatically, this virus will also encrypt your drives as well. So you have to be very careful. Offline backup is much better protection in this case.
Well, then that brings up an interesting question. If you have automatic synchronization set up, and backups typically use compression, if you can't compress it, you can't compress and encrypt at the same time. Because one thing makes something big and the security, the other one makes things small. Do you have to decrypt then use the actual backup on something to protect the drive?
All right, this was a long question. Let me
So
summarize it.
Let me
Summarize
try
the question,
to
please.
simplify this without repeating the question. While online, if you have a BitLocker encrypted drive, there's no need to I mean, the information is the information is in clear text, right? From the online standpoint of view of the operating system, when you zip that information, when you compress that information, it's in clear text. When you export it, it goes in clear text. It's not encrypted. To online protection, you're probably talking about EFS, encryption file system, which is using PKI to encrypt that information to your user, for example, to your certificate. And no matter where that information goes, it's going encrypted. Question?
Virtual TPM coming with new releases and so on. How will that and encrypted only work on snapshot backup technologies?
So virtual TPM and snapshot technologies?
If you do, for example, you encrypt your servers but no one will steal the disk file. But the question is how do you know?
Got it. So the question is about virtual TPM. But what I'm most talking about is TPM mobile. It's a different technology. What we're talking about is the hypervisor presenting a virtual TPM to the machines, right? So the question is now snapshots? That's a good question on servers. I don't know a lot about VTPM on hypervisors yet.
Please see me after the session. I'll write it down.
Yeah.
We come back to you.
We'll exchange contacts. Thank you.
Question? I can't hear you, sorry.
I'm sorry.
Can you use the microphone, please?
With the new technology, with the Microsoft BitLocker, in the past, it was not able to take over the TPM ownership and all that while encrypting it. Is it something they have improved on that side?
So if we can take the ownership, obviously we can. The thing with TPM 1.2 was that it was most times inactive on the hardware. And no, I mean, if it's on the BIOS, we cannot control that. Right? It was your physical decision to have the device inactive. With TPM 2.0, there's no option to deactivate that device. It's always enabled.
Okay.
Got it? Thank you. Okay, so here's the list of the protectors. So I just ran the command manage BDE, protectors add, interrogation mark, and this will give me the list of protectors that you can add. Right, so a lot of protectors that you can add to your BitLocker drives. From recovery password to TPM plus PIN and startup key, again, you can increase the complexity a lot, but it will be not that simple to boot your machine naturally. Okay, so those were protectors. Now going back to the metadata, and I, again, will do the small test just to exemplify how the information is kept. Remember that I have my VHD encrypted. It's not unlocked, right? I'll just use a standard X editor. We'll open this, and I want to take a look at my disk layout. There you go, so got all the information. Now I just want to look for the signature of BitLocker, which is FE, full volume encryption, file system, oopsie. And it should find something for me. There you go. So this is the volume boot record, what tells us that this is the information to boot the drive. And there you go. So this is the first signature that we see on a BitLocker encrypted drive, explaining that this is the sector to boot. Now, moving forward, if I search this again, I'll have 3 extra signatures, and these signatures are the locations where we store the metadata blocks containing those full volume encryption keys that we need to unencrypt the information. And we store more than one for recoverability purposes, because if we not find the first metadata block, we need to go to the second so we can access the system. And again, this key is encrypted by the volume master key, which in turn is encrypted by the storage root key or other keys that you decide to use, if not TPM. But again, TPM is highly recommended.
Does TPM or does encryption shorten the life of an SSD?
in SSDs?
No.
What's the question?
So the question is if encryption shortens the life of SSDs. No. Because again, you are going to write the information no matter what to that cell. So if it's going to be written encrypted or not, it's the same, I would say.
Like, I knew there was, a lot of write time, on a hard drive after you.
When you encrypt the disk, is that it? So with Windows 8, there's an option to do used space encryption only. So you won't encrypt the entire drive when you want to encrypt the drive. In Windows 7, that's by default. It encrypts from sector 0 to the last sector. In Windows 8, no. By default, only the space that is being occupied.
You need some updates.
Oh, I do. Yeah, most definitely. And there you go. And another thing is, so those blocks are we have a pointer for those blocks in system volume information. So let me show you that. So I'm going to my D drive. Now it's BitLocked, obviously, so I have to unlock the drive. Now I'm putting my password. Right, this is the protector to get the full volume encryption key. There you go, now it's unlocked. And what I'll do is I'll go to my D drive, which now is unlocked, and I go to the system volume information. And you should see some funny files inside, hidden files. There you go. Those files are pointing the information for the global unique ID of the disk and the sector where those metadata blocks reside so I can access the full volume encryption key. I think I haven't forgot anything. Oh, good. Oops, sorry. Let's go back to the presentation. Any other questions around this? No? I think I got it all. Yep. So let's move on. Pre-boot authentication. It provides, obviously, additional security. So security is always defense in depth. It's always adding more layers to be more secure. It can be a PIN, a password, or a USB key. You can actually use a USB key for the startup key of the system. You can also combine them, PIN and startup key. But it's extremely inconvenient in touch devices. Like the Surface Pro 3, a lot of customers that I know have TPM and PIN. And then we have to have the touch keyboard coming from the UEFI, and sometimes it doesn't work very well, depending on the manufacturer OEM and the solution that we are using in terms of encryption. And this is something very, very important to note. Surface Pro 3, it's a connected standby device, and it's not the only device in the market, right? There are other devices that are connected standby devices. Connect standby is simply those type of devices that have a specific sleep state. We call it deep sleep, where the machine, once you turn on the screen or the screen turns off automatically, it goes into a state of low power consumption, but it's still active, meaning that applications like modern applications wake up every 10 minutes, request a Wi-Fi or request a Wi-Fi connection if there's one available, connect to the CDNs that they are supposed to connect, and bring that metadata back so that you can have the live tiles updated once you turn on the machine again. And those connected standby devices, they are meant to be really fast on transitions. So if they are on deep sleep, if you press power, it's like instant. So it's like the machine was always on, all right? So those connected standby devices, the specification for those devices says that they cannot have direct memory access ports. And I'll explain in a bit how those kind of ports create an attack vector. But in those devices, having a PIN doesn't make sense, exactly because the TPM is protecting the volume master key. and there's no DMA port to do an attack. Okay? Again, TPM is sufficient for the majority of the scenarios. Move on.
All right, let's talk about attacks, attack vectors, and countermeasures.
Exactly. Sure. Question?
How is TPM only going to protect your laptop or tablet from being stolen? And you boot it up and the TPM comes off.
Then other
What is the
measures. So the question, I'm sorry, thank you. So the question is, how can TPM only protect your information if your laptop gets stolen and the machine boots up immediately, right? So passwords, online security should protect your operating system, right? Strong passwords, second factor authentication like biometric or smart cards, those are the things that are going to protect your operating system, right? Again, BitLocker is only to protect against offline attacks. But if your OS is secure, there's no way to tamper that. And again, if there's no DMA ports, there's always also no ways to get the full volume encryption key back from the memory. No question?
Yeah, what about some viruses like the actual TPM key and something does crash, that you able to pull that hard drive out and use that firmware TPM backup key?
So if the question is if your machine crashes or if you have any issue booting the machine or something, no worries. So you can take the drive out, and if you properly store your recovery key, you can access that volume in another machine with a recovery key. Now, you won't be able to boot the disk because it has a chain with the TPM, but you'll be able to recover your information, format the machine, clear the TPM, and take the ownership of the TPM again. It's very important to, not the BIOS, the recovery key from BitLocker. So when you encrypt the machine, you get a recovery key, depending on the option that you obviously enable. If there's no manageability, if you don't store that in Active Directory, normally it's saved in a text file. And that text file should be also stored in a protected area. Okay? If you have AD, and managing those keys to AD or uploading those keys to Active Directory, it will be on your computer object, the recovery key. Okay? Sorry, question?
As a follow-up to that, from a forensic standpoint, rapid key recovery and reconstitution of encrypted disk along those lines, is there a methodology that Microsoft provides to rapidly do that, or is it pretty much a tedious step-by-step process?
To recover the information or to clear the information? No, yeah. So what? Thank you. So the question I'm sorry, if we had any kind of methodology to do forensics, right, on encrypted drives to quickly recover the information or encrypt that information. Oh, no. No.
You can use it in case of some other product to do subsequent work, but it's just a rapid recovery.
No. I mean, the volume ID is there if you know the machine name, and if you have the encryption key or recovery key stored in Active Directory, you can script something to go to LDAP and get that. Okay, but if not, third-party drivers, or third-party, I mean, thank you. Thank you. Go ahead.
Question.
Oh, are you too? Thank you.
Yeah, I'm not sure if you answered the original question. So if you use TPM only and you boot from a disk that's a password reset disk, will you be able to reset the password to get access to the disk?
So the question was, if you use only TPM, and if you reset the BIOS password, is that?
If I boot like a password reset disk or USB key.
No. The volume is encrypted. So even if you use TPM only to protect the volume master key, there's no way that you will be able to read the encrypted volume. Okay?
Can you boot a Windows repair disk then?
Yes, it will ask you for the recovery key to access the volume. Okay? There was another question. Was that question? Thank you.
All right, let's talk about the attacks and vectors. So I think we all know what bootkit and rootkit is. Yeah? I think you saw it in some other sessions as well. So what is a rootkit doing, or bootkit? it's a very dangerous type of malware,
Exactly.
which sits deep in the platform. So we have our applications, we have our operating system, where you deal with another ATPs at the OS level, viruses, malware. But then we have a hypervisor if you're using it, and there are different attack vectors there as well. But the rootkits sit basically in the firmware in the BIOS, and it controls. So your antivirus, your classic protection method is not going to help you because it is out of that circle. So I think we all understand how viruses work, how rootkit works, right? So the question here is, the important thing is we have to focus on the layers.
Correct.
And these layers are really important, especially, he said it. Remember that beep sound when we connect to our computers? So
you turn on the machine, and obviously TPM comes in place, right? Or in newer machines, UEFI, which is the new BIOS, right? BIOS is dead. UEFI comes in place, and it checks itself to see if the signature is compliant, if everything is healthy or with the right integrity. If not, it restores itself. But if it is, it moves on and talks to the TPM. Can you click? There you go. So the first step is really to check the firmware digital signature and then talk to the TPM. The TPM will check if secure boot state is on through the PCR7. We'll then move on to check the signatures of the boot manager, and if the boot manager, and this is secure boot, right? If the boot manager is properly signed, if we trust that boot manager, we'll move on with the boot. If not, we'll ask for the recovery key. So it was like if the machine was tampered, someone tried to tamper with the machine. So if you got infected with a rootkit, and again, like Erdal was saying, there are multiple levels for the rootkits, but the ultimate ones are obviously the ones attacking the hypervisor and the firmware. You will not notice anything. So every single technology that you use in an online state, like anti-malware, antiviruses, process inspection, will not be able to detect that because it's on a lower level. So to protect the machine on those scenarios, once you boot the machine, it's all about secure boot. Secure boot validates every single boot file that we need for Windows and also its own state on UEFI to see if everything has the right integrity. If not, we'll ask the recovery key. So it's also up to you then to understand what has changed. Have I done anything to my machine to trigger a recovery key? If not, you should obviously investigate, right? So the countermeasures for bootkits and rootkits are the UEFI with secure boot, also quite common nowadays on your machines, having the TPM to make sure that the secure boot is enabled. Otherwise, the attacker can go into the UEFI and disable secure boot. You should also protect your UEFI with an admin password. Moving for the boot, we can also have digital signatures checking for everything that runs in Windows with trusted boot, and then measure boot that takes actually measures from the system in terms of software and hardware and stores it outside of the machine.
Demo.
Okay. Let me go to this. Is it?
You are number 8.
Yes. Thank you. So very simple to check if you have the PCR7 and secure boot. So let me go again to manage BDE. And now I'm going to, obviously, to my system drive, because that only applies to system drives, not to fixed drives or removable drives, right? And as you can see, I have my PCR validation 7 and 11. 11 is the BitLocker access control to actually trigger something on that PCR and ask for the recovery key. But PCR 7 is the one for secure boot state. And you can also verify that in your group policy, because you can actually define which PCRs you want. By default, it's the most secure also, but you can trigger other ones if you want. Just go to your computer configuration, admin templates, system. Here you have, I'm sorry, not system, Windows components.
Yes.
Thank you. BitLocker drive encryption. In here you have all of the policies that you can apply to the different set of drives that we support, from fixed, OS, or removable. And naturally, the PCRs are only applying to the system drive. And you can see that there's a different GPO for UEFI and non-UEFI hardware. And here you have all of the PCRs that are available for you to activate. But by default, the recommendation is 02411, or like in Windows 8.1 in this machine, my machine, it's only the 7, which is the secure boot state, and 11, the BitLocker access control. Okay. Any questions around this?
Let's talk about more attacks and countermeasures.
Yeah, let's go. So we went through bootkits and rootkits. Let's go to DMA. Exactly those things that I was talking about. If your computer has a DMA port, like a FireWire port, then it's going to be used as an attack vector, and it's one of the most commonly used attack vectors. DMAs, part of their design is actually to have direct access to the memory. So nothing is controlled. There's actually no authentication, no control method of what a FireWire device is doing with the memory. So it has arbitrary access, read and write access to the memory, and it can dump all of the information to a secondary device like a mass storage, and it can dump all of your memory. And then the attacker naturally gets that dump, use a couple of utilities to scan for AES keys in that dump file, and there you go. Now you have the full volume encryption key. And again, this is not only a BitLocker thing, right? This is every single encryption technology in a point in time has to save the encryption keys in RAM to unencrypt information from the disk and actually make the operating system work.
All right,
so
then.
How can I protect this?
Very hard, rocket science. Disable your DMA port. Where? Either in the UEFI or BIOS. What else?
You can destroy them if you want.
Yeah.
Epoxy glue, a hammer, why not?
Oh, I wouldn't recommend that much.
Okay.
All right, what about putting a password also in the BIOS or UEFI layer? Why? Otherwise, I can just go and enable that port again.
Exactly.
What about?
You can also block the drivers in Windows, right?
What about the KB article?
That's the serial bus protocol that you can also disable from Windows. But again, it's always by layer. Please understand that you should do everything here if you really want to protect your computer and if it has DMA ports. If you need them and if you want to be more protected, there's also other things that you can do, like disabling standby. And really, in this case, have pre-boot authentication. Have like a PIN to protect that. If you have standby enabled, what happens is that we will skip the pre-boot authentication. We will not go through it. If the machine goes into a hibernation, we will have to go to pre-boot auth, right? So we then protect from reaching to the online OS and loading the device, loading the driver, and dumping the memory.
And most probably the most important tip, which is hidden right on the bottom, physical security. Do not leave your machine unlocked,
and unattended.
Especially if Milad is around.
Exactly.
And you know, unattending is also why. That's in rule number 1.
Right. Again, a lot of countermeasures that can apply, but like I said, on the majority of the newer devices nowadays, there's no DMA ports. So this is becoming less of an attack vector, but there are still a lot of devices, those powerful devices, that have DMA ports.
Should we talk about the cold and warm boot attacks as well?
Oh yeah, let's go there. So the memory remnants attack is those attacks where the computer is on, right? Someone stole the computer, maintains the computer on, and then in their lab, what they do is they shut down the machine and they boot another OS through USB or network or whatever the attack is. And then they actually dump the memory again. Thing is that the majority of the DRAMs, they can hold up the information even though the machine was shut down by seconds or minutes. And another technique is to actually freeze the RAM to maintain the information during more time on those DRAM modules. And then they can even extract those DRAM modules, put it in another computer, run that USB or CD OS, and dump again the memory. And trying to then in that dump file, looking for the pattern reserved AES keys and making use of them. Okay. So that's known as the cold warm boot attacks. There's a nice video and a nice paper from the Princeton University from a couple of people from the university itself and independent hackers that you can look online to understand more about this attack. What else? And how can we secure this?
Of course, UEFI with Secure Boot again. We did talk about it.
Hence why, if you use Secure Boot, you cannot load an untrusted OS. So you're safe, right? Windows is a Secure Boot certified OS. Right? A Secure Boot is a technology from UEFI, from Trusted Computing Group. It's not nothing from Windows. We take advantage of that feature because all of the bits are signed and are within that trusted database of signatures of the UEFI itself. So if you try to boot a Ultimate Boot CD or something like that, it will not work because it will not trust the operating system. Right? So it's really important to have Secure Boot enabled on your devices. And I do know, I see it a lot. I see it quite frequently each time I visit a customer. They're using new machines with Windows 8 or Windows 8.1, but they're still using the UEFI in compatibility mode, which will not allow them to take advantage of the Secure Boot. So please make sure if you're on a deployment of Windows 8.1 or if you're thinking about deploying Windows 10, make sure that you have all of your machines in UEFI mode and with Secure Boot active.
It's a very smart idea to put the password and, more importantly, disabling the USB port. Why? Refer to my previous sessions.
There's a question. So if with Secure Boot enabled, can we boot Windows PE? Yes. Again, Windows PE is a Windows, right? It's just running in RAM, so it's signed.
Could that OS be used in the gold OS or gold?
It could. Thing is, again, you can, there are a couple of utilities that are open source. You can extract that. That's true. Okay. Thank you. So disable boot from USB and PXE. And again, this is highly complex to do on systems with fixed memory. Another example is the Surface Pro 3, where you have no access to the DRAM modules. You have to literally break the machine to access the DRAM modules. And once you do it, you might even damage the memory. And recently, there was a study from the Defensive Department from Canada, where they actually tried to see if this attack is still viable or how viable it is. Because when it was presented back in 2008, if I'm not wrong, they said it was highly viable. We could extract a lot of information from the DRAM modules, even after a couple of minutes. And this scared everyone, like in the industry, right? Thing is that this DoD department from Canada, they told that it's not that simple. A lot of the times, they could not get information from the RAMs, probably because it's newer hardware, and they are more volatile. They will store the information, or they will obviously not store the information for that amount of time. And even when they could dump a lot of information from those DRAM modules, there were no keys available, or only a small portion of the key available. So they could not restore those encryption keys and read the information back. Question? I'm sorry, I couldn't hear.
What version of WinPE supports Secure Boot?
I would say 5, which is coming from Windows 8. 4 or 5. 5 is a Windows 8.1, yeah. So which version of Windows PE would support booting? with Secure Boot on, use the Windows PE versions from Windows 8 and Windows 8.4 and 5. Thank you.
One
Go
more
ahead.
question there.
Question. Definitely. So the question is, to use Pixie Boot, if you have UEFI and Secure Boot on, if we could boot and provision those machines, yes, you can. When you switch from BIOS to UEFI, those DHCP options that you use normally to do the bootstrap, they will not work. You have to use IP helper tables. That is actually the supported method. The DHCP option was always a workaround to do Pixie Boot. Okay, thank you. Question?
Just on that, if you are on legacy and you're changing to UEFI, you might have to adjust your
Oh yeah, so if you're using the compatibility, thank you. So if you're using compatibility switch or compatibility service, which is like emulating the BIOS, and you have a UEFI machine, if you switch to UEFI, you have to reformat a machine because the partitioning table changes. We move from MBR to GPT. Thank you. Okay, so there's a lot of attacks that can be applied to encryption technologies or encrypted drives. We just refer to the 3 most common ones, right? But after presenting this, 3 type of attacks, which are the most common once again, what are the best options to protect yourself? So here's the search for the unicorn. And again, this was the slide where I had the Ninja Cat, but I could not. When we launched Windows 8.1, there were a couple of articles outside, public articles, and even papers stating that Windows 8.1...
Here's the Ninja Cat, by the way.
Oh yeah, the Ninja Cat, there you go.
We are not allowed to display it there, sorry.
So there were a couple of articles, technical articles, and some papers that refer that Windows 8.1 had this new protection that would block newly attached devices, newly attached DMA devices to actually load if the machine was on and if it was locked. Unfortunately, that is not true. That was our goal, but it was not ready in Windows 8.1. Okay? It will be in Windows 10. Meaning that Windows 10, what happens is if you're signed in, and if you lock your machine and you leave your machine unattended, if someone tries to plug in a new DMA device to dump the memory, it will not be loaded. Only when you actually log on to the machine, that device will be loaded. So it's an awesome protection to prevent those DMA attacks. Okay? So you have to lock your machine. That's why we said that lock policies, very important, right? Well, people should, right? And again, if people do not lock it, that's why we do GPOs to have a very low inactive time to make sure that machine is locked and protected. Now, let's look into this table to see what are the best options for you, referring to those 3 types of attacks, and Windows 8.1 with no TPM, Windows 8.1 certified device, which has to have a TPM or a connected standby device, I mean, and Windows 10 also. So for bootkits, like UEFI, Secure Boot, and again, protect your UEFI with a password. That's one of the best protections you can have. And also the antiviruses and anti-malware, everything that you can have in inspection online. Now, coming with Windows 10, there's something new, and I'm pretty sure that you heard either in build or during this week, which is called Device Guard. Device Guard is like an app locker. Anyone knows app locker? Yeah. So app locker is, you can define fine-grained control policies on which applications like exe, bat files, scripts, or even modern applications, a user, even if it's an admin user, can run portable or installable applications. Device Guard will make use of that, which is code integrity, and you can have your own signature, your PKI signature, inside a UEFI and only allow the OS to run applications which were signed by yourself. So everything else is not executed. And the best analogy that I can get to you, might not be the best one, is Surface RT. Anyone remembers the Surface RT? Awesome. We love you.
I don't remember.
So the Surface RT had an ARM CPU and only allowed applications to run if they were signed by Microsoft. So even if you had applications compiled to ARM in Windows, there was no way that you could execute or install them. All right, so the machine gets really, really protected. So device card is awesome, and it's coming also with Windows 10. Now moving on to DMA, you know the drill, right? Disable those ports, password protect UEFI and BIOS, disable the SPB2, make sure that the machine is not left alone and unattended and unlocked, obviously. And also coming with Windows 10, we'll try to mitigate that with that new policy where DMA devices, newly attached DMA devices, will not be loaded. The memory attacks, again, password protected firmware, secure boot should be on, and try to use devices if you really need to have devices. How to say this? So if you really want to be mobile and containing a lot of private information or confidential information, and you BitLock that, and it's highly important, and it might be a target of attack, try to choose devices where it's extremely difficult to remove those memories, to get access to those memories. Because again, even though you might boot a Windows PE, even though you might run some kind of utilities to dump the memory, if they do not have access to the memory to freeze it, then the percentage of the attack being viable goes like to almost zero, because the memory remnants will not be there. Information will just go away. Like I said, that recent paper showed that it's very difficult to get the information from the RAM. So key takeaways. You should use the Windows 8.1 or latest operating system. Windows 10 is coming soon, we hope. UEFI, please enable that. Secure boot and TPM. Once again, connected standby devices like the Surface Pro 3 do not have DMA ports, so the DMA attack kind of disappears. Kind of, no, it actually disappears.
Yes.
So it's not a problem anymore. And even if you have machines with DMA ports and you need to use them, Windows 10 will add that extra protection for yourselves. Force the machine to lock after the inactive time. There you go, group policies again being major. Right? If your users left the machine unattended, it should lock after a couple of minutes. Ensure TPM lock is also enabled with Windows logon failures. If you fail a lot of times, consecutive times, the Windows logon, it will actually lock the TPM and the machine will not boot the next time. Use strong authentication. And I refer there to the next-gen credentials, which is also coming with Windows 10. We will try to make it more consumer-friendly and also to enterprise-friendly. The second-factor authentications, from biometrics to iris scanning and using cell phones and tokens and whatnot. So Windows 10 will also help a lot on that area. Force hibernate if applicable in those scenarios where you also have the DMA port and you want to have the pre-boot authentication. Now, if you have the pre-boot authentication, if standby is enabled, if someone turns a machine on, it will not go through that authentication process. Last but not least, security is a mindset, not a conjunction or a correlation of products and features. And defense is always done in depth, right? Layered approach. It's not only the UEFI, it's not only the TPM, it's also a secure OS with all of those technologies, all of those other products like AV, anti-malware to protect your system, and the group policies, and the training also for the users, why not?
For this, please refer to my previous session if you didn't attend, Advanced Windows Defense. We did show, me and two other speakers, Max and Hussein, we showed why it's important to have layered defense and how you can get owned even in a stage live. So for everybody who didn't watch it, please go watch it and you will understand this session's value much better, because if I was a victim, by the way, as the speaker, if I did listen to my own session to this session here,
you'll be more protected.
I wouldn't be hacked in the session. Of course, this was a message for all of us that even we can get hacked. And if we get aware, then we can implement some sort of protection.
Correct.
It's really important.
The
And
more
cost
you are
was?
aware, the more protected you are, naturally.
And the cost was?
The cost was your machine is infected, you're running things on it.
Check Twitter. By the way, don't forget to tweet, please, about the session. And all of you will getting this back. We're going to show the handle now. I think that's it.
Yeah, so once again, thank you for attending. We still have 4 minutes for questions if you guys want to.
Please, please, please make sure you tweet, okay, about the session. It's really important.
Can you use the microphones? Can I ask you to do that,
Evaluation.
please? Thank you so
One
much.
of you want to speak over the Twitter? Please come and get your... We have also 3 here
Thank you.
to give away. I'll leave it to the master. Here we go. You select your winners.
Thank you.
The winner from Twitter, please come pick it up.
Okay, so here's a question. Can you clarify again under what circumstances the TPM will release the key in a threat model where normally an insider is the threat actor? So we can't use pre-authentications. We can only use the TPM only. Under what circumstances will the TPM release the key?
So the TPM does a lot of integrity checks. When actually you boot the machine, there's a huge amount of checks the TPM does. If we detect anything outside of what it's expected, the TPM will not release the storage root key to unseal the VMK. So those... Yeah, I showed you the GP edit. I can give you the list now if you want also. But if you go to those PCR checks, the platform measurements, you'll see every single one that you can activate. By default, those ones are more than enough, like checking the secure boot. If you check the secure boot, if someone infects your machine, secure boot will handle the rest. So again, it's multiple layers, not only the TPM, but also the UEFI with secure boot. If you boot from a Windows P drive, the TPM will not unseal. No, I'm sorry. No, only for the system drive, correct? Only for the system drive. If we detect that there's nothing outside of the normal, we will unseal the VMK. If you boot Windows P, you'll have to provide the recovery key, which is that 48-bit digit key to unlock the system. Okay, you're secure. No worries. Thank you.
Because the group policy, when you change the PCR, it requires you to really doesn't change things until you release the TPM.